I am Shanmuga Kumari from the Department of Information Technology. Today we are going to see digital circuit design from the digital principles. Okay, let us begin with the basic gates and the universal gates. Okay, the basic here there are the three basic gates: AND, OR, and NOT. Then we are going to see the universal gates of NAND, NOR, and XOR and XNOR gates. Okay, these are the block diagram of the logic gates. Okay, there are the three categories of logic gates. The first one is the basic logic gates, second one is the universal logic gate, then third one is the other logic gates. Okay, what are the basic logic gates? We can say at an AND gate, NOT gate, and OR gate. The universal gates are NAND and NOR gate. Okay, then remaining other gates are XOR gate and XNOR gate. Okay, let us begin the class with the AND gate. Okay, first of all we must know the AND gate truth table. Okay, so here there are the two inputs A and B. These are the two input. This is the first of all you can see the PowerPoint, the logic diagram of the AND gate. There are the two input. Okay, so you can see in the PPT A and B, these are the two inputs. The output is the A dot B. So we can derive from the truth table. What are the inputs for the truth table? 0 0 0 1 1 0 1 1. Okay, so we can say 0 and 1. 1 is the on state, 0 is the off state. We can say low value or high value, true or false, if anything we can say, but here we can say at low value and the high value. 0 is the low value and 1 is the high value, 0 is the low value. Here we can see the truth table from the diagram. 0 0, the 0 0, the answer is 0. 0 1, the answer is 0. 1 0, answer is 0. 1 1, the answer is 1. Here we can for the AND gate, if you can see the truth table, output of the truth table. If the two inputs are high, it gives the result is high. Okay, we'll see the last input alone, here the output is 1. Remaining all the inputs are 0. That is called AND gate. Okay, so we can see the circuit diagram. The plus 5 volt. Here we are going to draw the AND gate by using the switching the diagram. Okay, here we need what are the things for the diagram. Okay, first one is the volt, and that there are the two switches and AND gate. For the result we are indicating by the LED lights. Okay, so first I show the circuit diagram. Next I show the output for the, by using the circuit maker I show the output for you. Okay, first of all I connected with the plus 5 volt. Then there are the two switches S1 and S2. The two switches are connected with the AND gate. Then the output of the AND gate is connected with the LED. Okay, the LED shows the result. If the light is on, the result is 1. If the light is off, the result is 0. Okay, so this is called AND gate. So from next we are going to see the OR gate. Okay, we'll see the difference between the AND gate and OR gate. AND gate is somewhat ellipse. The diagram shows the ellipse. Okay, but OR gate is like a curve. The OR gate is like a curve. Here these are the two inputs A and B and the output. Okay, we can see the truth table for the OR gate. Here if for the truth table of the OR gate, if any one of the input is 1, the result is 1. That is called the OR gate. Okay, but we can see the AND gate, if both inputs of 1, the result is 1. But OR gate, if any one of the input is 1, the result is 1. That is called OR gate. We can say in simply AND gate is somewhat strict. If both inputs are 1, we can say the result is 1. Remaining all the inputs are 0. But OR gate is somewhat liberal. Okay, if any one of the input is 1, we can get the input is 1. For example, 0 0, the 0 0 is always 0. 0 1, answer is 1. 1 0, answer is 1. 1 1, answer is 1. Okay, these are the difference of the OR gate and AND gate. Okay, next we move on to the NOT gate. Okay, the NOT gate is, there is a small triangle with the bubble symbol. Okay, this is called the NOT gate. Okay, there is only one input for the NOT gate. If the input is A, the answer is A bar. If the input is B, answer is B bar. If anything, if I am saying the low value, the gate is giving the high value. If I am giving the high value, the gate is giving the low value. It's an inverter. The NOT gate is called inverter. You can see the diagram. You can see the truth table. If A is equal to 0, output A is equal to 1. If A is equal to 1, the Y is equal to 0. Okay, so here also I showed with the circuit diagram. Here also I am showed the circuit diagram. The plus 5 volt, from the 5 volt I connected with the switch, then I connected with the NOT gate, then last we are showing the LED light. Okay, if the switches are connected, they connected at both, that is called the A value is 1. Okay, if the switches are unconnected, the value is 0. Okay, for the NOT gate, if the result is 0, if the input is 1, the result is 0. If the input is 0, the result is 1. Okay, let's move on to the AND gate. Okay, these are the basic gates. These are the basic gates. What are the basic gates? AND gate, OR gate, and NOT gate. Okay, the AND gate is somewhat strict. If the both inputs are 1, it gives the result is 1. OR gate is somewhat liberal. If any one of the input is 1, the result is 1. But NOT gate is getting only one input. If A is 1, the answer is 0. If A is 0, answer is 1. If I am saying the low, the giving the output value is high. If I am giving the high value, the output value is 0. That is called NOT gate. These are the building blocks of the basic gates. Okay, the next we are going to see the NAND gate. Okay, so the NAND, you can see the diagram from the PowerPoint. The NAND gate same like the AND gate. NAND is called AND gate plus NOT gate is called NAND gate. Okay, NAND gate is AND gate plus NOT gate. We can say not AND gate. We can say that is the not AND gate. Okay. Okay, we can see the truth table. We can see the truth table. First, there are the two inputs A and B, 0, 0, 0, 1, 1, 0, 1, 1. For the normal AND gate, what is the result? If the both inputs are 1, the result is 1. That's it. So this is called AND gate. So what we are going to study here? We are going to study here NAND gate. What do you mean by NAND gate? Not AND gate is called NAND gate. So we can reverse it. See, Y is equal to A dot B. NAND gate answer is equal to Y is equal to A dot B the whole bar. Okay, so from the whole bar we can say 0 is the output of the 0, 0, the 0 is 1, 0 is 1, 0 is 1, 1, 1 is 0. This is the output of the truth table. You can see the truth table. You can see the truth table output of the NAND gate. What are the output of the NAND gate? That is in reversible of NAND gate is called NAND gate. You can see the diagram from the truth table. 0, 0, 0, 1. I am going to reverse here. 1, 1, 1, 0. That is the output of the NAND gate. Okay. So now you can see the logic diagram of the NAND gate. Okay. The same like the AND gate, but in proceeding that there is a small bubble is there for the NAND gate. The NAND gate is not AND gate is called NAND gate. Okay, so you can see the circuit diagram and the output of the circuit diagram. See you can see the output of the circuit diagram. The plus 5 volt from the first diagram, plus 5 volt. There are the two switches S1 and S2. Then I am connected with the AND gate. The result of the AND gate I connected with the NOT gate. Okay, the result of the AND gate I am connected with the NOT gate. Then I am connected with the LED light. Okay, there are the two inputs. Okay, S1 and S2. S1 and S2. Okay. First of all, I connected with the NAND gate. Then next, I connected with the NOT gate. Okay. So from the first diagram, I am giving the result is 0, 0. First diagram, I am giving the result is 0, 0. How can I say 0, 0? The S1 and S2, the two nodes are not connected. It is open. S1 is open and then S2 is open. If it is open, that is indicated by the 0. If it is closed, the switches are closed. It is called 1. If the switches are opened, it is called 0. Okay, we are giving the input is 0. If the switches are closed, we are giving the input is 1. Okay, you can see the both diagram. The first we are giving the 0, 0. First diagram we are giving the input is 0, 0. What is the output of the NAND gate? 0, 0. For the 0, 0, what is the output of the 0, 0? You can see that from the truth table, if the input is 0, 0, output of the NAND gate is 1. That means the LED is on. You can see the diagram, the light is on there. Okay, so next one, they are giving the input is 1, 1. The switches are closed. The switches are closed. Okay, so first input is 1, the second input is 1. You can see the output of the LED light 1, 1. You can see from the truth table 1, 1. What is the output? 0. See the light, LED light also, which is not on. This is off. Okay, the light is not emerging here. Okay, this is the truth table of the NAND gate and the diagram and the circuit diagram of the NAND gate. Okay, the next we are going to see the NOR gate. So we can say the NAND gate is not a AND gate, NOR gate is not a OR gate. Not a OR gate is called NOR gate. The same OR gate here, from you see the logic diagram, the same OR gate. From here proceeding, they are connected with a small bubble is there, that is called a NOR gate. Okay, there are the two input A and B, the output is. Okay, so from the we can see the truth table, first A and B, these are the two inputs. Then next I'm showing here I'm showing here output of the OR gate, y is equal to A plus B. What do you mean by NOR gate? The NOR gate is the inverse of the OR gate is called NOR gate. Okay, that is the inverse of the OR gate is called NOR gate. What is the result of y is equal to A plus B? 0, 1, 1, 1. So the reverse of the OR gate is, you can see from the 0 is replaced by 1. The 1 is replaced by 0, 1 is replaced by 0, 1 is replaced by 0. What is the output of the NOR gate? 1, 0, 0, 0. What is the output of the NOR gate? You can from the truth table you can see the two inputs. The first I am showing the OR gate result, then I am showing the NOR gate results. Okay, so here also you can see the circuit diagram. Okay, circuit diagram. The first S1 switch is 1, S2 switch is 0, 1, 0. What is the result of 1, 0? You can see from the truth table, S1 result is 1, that the switches are closed, so there is input is 1. The switches are open, so there is input is 0. 1, 0. What is the output of the 1, 0 from the NOR gate? 0. See, the LED light is not, that's off. There is no light is on here. Okay, the light is off here. Okay, then the result, you see the next diagram of the NOR gate. Here S1 is 0, S2 is equal to 0 because the switches are open. So we can say the 0, 0. 0, 0 means what is the output? The output, the NOR gate output 0, 0 means output is 1. So we can see you can see the diagram. You can see the switch diagram. The light is on. This is the output of the NOR gate. Okay. The next so this is the NOR gate and NAND gate and NOR gate. NAND gate is the not AND gate. NOR gate is the not OR gate. Okay, next we are going to see the XOR gate. Okay, next we are going to see the XOR gate. Okay, so you can see the logic diagram of the XOR. You can see the logic diagram of XOR gate. They're slightly like a OR diagram, but in before that there is one curve is there for the XOR gate. Okay, so you see the truth table of XOR gate. You can see the truth table. First of all, we see the input 0, 0, 0, 1, 1, 0, 1, 1. We can see the output of the XOR gate. See the output of the XOR gate. If the inputs are different, it gives the answer is 1. Okay, we can see the in between 0, 1 is giving the result is 1. 1, 0 it's giving the result is 1. If the inputs are different, if the inputs are different, it gives the output. Okay, if maybe a 0, 1 or 1, 0, it gives the input is 1. If the same inputs are there, 0, 0, 1, 1 is giving the result is 0. Is giving the result is 0. Okay, next of all, we can see the circuit diagram of the XOR gate. Circuit diagram of the XOR XOR gate. Here I am saying, here you see the circuit diagram of the XOR gate, the plus 5 volt, there are the 2 switches, then I connected with the XOR gate, the result. What is the input of the first diagram? What is the input of the first diagram? 1 1 1 1. What is the 1 1? What is the result? You can check with you can check the result with the truth table. What is the result of 1 1? The result is 0. You can see the LED light. The light is off there. If the input is 1 1, the result is 0. Okay, what do you mean by XOR gate? If both here, what do you mean by XOR gate? If the both inputs are different, it gives the output. Okay, if the inputs are same, it gives the output is 0. If the inputs are different, it gives the output is 1. Okay, so for the second diagram, 0 0 1. What is the output of 0 1? You see that truth table 0 1. What is the output? 1. So for here the light is on here. Okay, this is called a XOR gate. Next we are move on to the XNOR gate. XNOR gate. The same as you can see that you can differ the diagram of XOR and XNOR gate. Okay, XOR and XNOR, there is the same. For the XNOR, in preceding we are connected with a small bubble is there for the XNOR. The same diagram of XOR, you can see the same you see the PowerPoint, the same diagram of XOR gate, but which is preceding with the small bubbles is there for the XNOR gate. Okay, okay, the logic diagram is okay. Next we are going for the truth table. See the truth table for the XNOR gate. For the XOR gate, what I said for the XOR gate, if the inputs are different, it gives the input. Okay, but XOR gate, if the inputs are same, it gives the output. If the inputs are same, maybe 0 0 or 1 1. If the inputs are same, it gives the output. Okay, so for 0 0, it gives the output is 1. 1 1 is giving the output is 1. Okay, you can see the first one is the last one alone, it's giving the result. Okay, for you can check with the circuit diagram. You can check the circuit diagram. First result S1 and S2. What is the input of S1 and S2? 0 and 0 0 0. What is the result? 1. Here the LED light is on here. From the you see the circuit diagram, the light is on. Okay, for the next you can see the next diagram, the input is 1 0. The input is 1 0. What you can see the truth table, what is the output of the truth table? 0. Okay, the light is off here. The light is off here. Okay, these are the gates. Okay, first of all, we saw the basic gates and or not. The next we saw the NAND gate and NOR gate. The last we saw the XOR gate and XOR gate. From the one line we can say AND gate is somewhat strict. Strict means if the both inputs are true, it gives the value is 1. OR gate is if any one of the input is 1, it gives a result. NOR gate just reverse it, inversion, that is called NOT gate. Okay, NAND gate, it is the inverse of, it's a not AND gate is called NAND gate. What do you mean by NOR gate? It is a not a OR gate is called NOR gate. The finally XOR and XNOR, we saw that. What do you mean by XOR and XNOR? The XOR got if for the result of the XOR gate, if the inputs are different, it gives the output. But the XNOR gate, if the inputs are same, it gives the output. Okay, thank you girls. We'll see you on the next class. Thank you.